Hello, and welcome to the session on machine learning. What is machine learning? Machine learning is a subset of AI which focuses on the idea that machines can learn by itself from the data. So instead of programming the machine for a specific task, you give it the task, you give it the data, and let the machine figure out patterns and then make decisions and make predictions or do whatever is required to arrive at the conclusion or solve the problem. Machine learning is categorized into three broad categories. The first one is supervised learning. The second one is unsupervised, and the third one is reinforcement learning. Now let's look at what is supervised learning. So basically, in supervised learning, we supervise the learning aspect. So when we give data to machine, we create a set of labeled data, meaning with each data we provide a tag that this is what this data is. And then we initially supervise the way the machine should learn, and that is where it has got its name from. So this is being done on labeled data. Let me try to explain what this labeled data is and how this supervised learning is being done. Let's take an example. You all know what Halloween is, right? And suppose you go out, or you went out on this trick or treat, right? You came back with a bag full of chocolates. Now these chocolates are assorted. Everyone did not give you the same type of chocolate. So you have a big bag of chocolates which contains chocolates, a lot of chocolates, a lot of candies, a lot of sour patches, a lot of cookies, right? And gums, and several other types of things, and it is all assorted, it is filled in this bag. Now you got home, and somebody, one of your parents, or elder brother or sister, somebody starts teaching you how to organize this. So what they do is they pick up a candy and they say, okay, you put this candy here, or this was chocolate in my case. So C's are all chocolates, right? So they said, okay, you put all chocolates here. They said, okay, this is a chocolate, this is a chocolate, this is a chocolate, you put it here. They asked us to create another label or another category, and they said, all the sour patches come here. So this sour patch, it comes here. This sour patch, it comes here. So essentially what they're doing is they're teaching us that this is a sour patch, this is a chocolate, this is a candy, and this is a cookie, and this is a gum, right? They do that with, say, 5 chocolates, 5 sour patches, 5 cookies, 5 gums. So we have all these categories now, and we learned what is what, correct? Now for the remaining chocolates, now you learned that this is a chocolate, so this goes here. And when I pick up this one, okay, this is a candy, so it goes in its bucket. I pick this one up and I'm like, okay, this looks very similar to the gum, so it goes to the gum, right? So even though the chocolate might not be the same, but looking at the texture and the pattern and stuff, I was able to do that. So how did I learn about this data? Through those 5 chocolates that I was taught that this is a chocolate, or looking at those 5 sour patches. So now in this case, the data, which was this unit, was labeled that this is a chocolate, This is a Sour Patch. This is a candy, right? Now, with that, when a similar kind of learning is or in a similar fashion, when we teach the machine, it is called supervised, because somebody is supervising that learning. Now let's come to unsupervised learning. In unsupervised learning, there is no labeled data, so that is being done on unlabeled data. Okay? Now what does that mean? Let me take an example for this as well. You were a kid, you went to the school. Say you went to the first day in your middle school. You were dropped off to the school, your parents went away from the gate. You went inside and you saw hundreds of students there, might be around 40 or 15 just in your section, right? Now you started looking at the behavior, the pattern, and how each of the kids were doing. And based on that, you identified your group. You formed your group, right? So nobody taught that to you. What you did is you were put in that huge data set, all the students. You figured out the pattern that was compatible to you, and you became a part of that. Right. Now, in a very similar way, in case of machine learning, what we do is we give a huge set of data to the machine and let it learn by itself. And now, when the machine is doing that, there is no label to the data, but it is able to figure out patterns, right? And it says, okay, this is P1, this is P2. There's no name to it, but it is a cluster. It is a group, right? It is a pattern. So that is how this kind of learning is being done. So take an example. Netflix. We are using this unsupervised learning a lot, and that is how different clusters are created, and every user, based on what they see, how they consume the data, where do they live, what language they prefer, what kind of movies they like, based on that they are put in one or different categories. Okay. And now if there are 5,000 people in this P1 and 7,000 in this one, and for this group there is a list of characteristics, right? Based on that, this category was created. Now if I fall here, then if people in this group start liking a particular movie, this movie will be recommended to me as well, because I belong to this category of 5,000 and my traits are very similar to their traits. So if they are liking something, I might like it. And that is how these recommender engines work. Okay, now let's come to reinforcement learning. So this reinforcement learning is something similar to what we all have gone through as kids. If you do this, you get a prize, an award. If you don't do this, or you do it wrong, you get punished. So this reinforcement learning is something very similar in that when we let the machine perform a task, and then we either reward it if the action was right, or we punish it and teach it to do the right way. For example, we are trying to teach the machine to play chess. Now, with every move, if the machine is making the right move, it gets a thumbs up. it gets a pat on its back. If the move is wrong, we correct it and we give it a penalty or we give it a thumbs down. So that is how the machine starts learning. With each move, it learns that this is right and this is wrong. And that kind of learning is called reinforcement learning. It is also used in, say, self driving cars, different types of games and stuff. Okay, now let's look at some of the subtypes of all these machine learnings. So, what are the different subtypes of these machine learnings? Basically, this supervised learning is of two different types. This doesn't work. So, supervised learning is basically of two types. One is classification, and the other is regression. Now, what type of problems each of these solve? So, the classification is so any type of predictions, they basically come here. So, for example, you want to predict whether it is a spam or not a spam, or any type of image classification, whether it is a cat or it is not a cat, or any kind of diagnostics and different types of customer retention cases. Yeah. So all the places where we want to classify it into one or the other bucket, we use classification. Now, where do we use regression? Right. So regression is used mostly for forecasting, weather forecast, market forecast, and it is also used for, say, you want to predict what is the life expectancy in a particular region. So all those kind of things are, all those kind of predictions are being done by this regression. In case of unsupervised learning, we have two different types of unsupervised learning. The first one is clustering, and the second type is dimensionality reduction. Now, let's look at what is dimensionality reduction. Say you have a large table with 100 columns, and say it is pertaining to real estate. So it has a huge table with 100 or 200 columns with a lot of data, right? Now, looking at this huge set of data is difficult. When we want to get some information out of it, might be we don't need all the columns, or we need a reduced a, a view of data where, without losing the essence of everything, we are reducing the number of columns. Let's take an example. So I have the city, zip code, number of bedrooms, number of bath, total area, whether it has one car garage, two car garage, etc., etc. Right? Now, what I wanted to know is what kind of price trend is going in this a particular locality. Now, while everything is important, but for that problem, if I reduce that to this, where I have the city or the zip code and per square feet price, right? So what I'm doing is I am reducing the dimension of this large table to a small table, yet retaining the essence. So that is basically what dimensionality reduction means. What type of problem is being solved by dimensionality reduction? Big data visualization or meaningful compression, structure discovery, feature elicitation. So those kind of things are being solved under this. So what are the different types of problem we solve by clustering? So one, we saw the recommender engine, market segmentation, target marketing. All those kind of things are being done by clustering. The last one is reinforcement learning. Now, this doesn't have any subtypes, but let's look at what kind of problems it can solve for us. So, one, we saw gaming, self-driving cars, um, different type of real-time decision makings. That is also one place where we use this a lot. Robot navigation. So a robot has to navigate. How does it navigate? How does it learn? That is also reinforcement learning. Skill acquisition. So many of those things use reinforcement learning. So these are the different types of machine learning algorithms and their subtypes and what they are used for in which problem areas. In the next video, I'll be talking about LLMs. So see you there. Bye bye.